Okay, so let's just do a couple more examples here with reactions of acids and metals.
Ooh, no.
Isn't it nice knowing you don't have to save the notes because it's online?
That is nice. Okay, remember that for this you're going to be using table J in your reference table to determine the metal reactivity. And the key here is that any metal above H2 in table J will react to produce hydrogen gas and a salt. And so we call this a single replacement reaction because that's indeed what it is. We have our metal hydrogen that's going to be kicked out as the metal replaces it. So if I said to you, we have zinc solid plus HCl gas or aqueous acid, and I want to know if a reaction would proceed.
What's that after H2O gas or H2 gas?
And a salt.
You forgot the and.
Yeah.
Oh, thank you. Yes, I did. So for this reaction, we need to look and find zinc, and we need to find hydrogen. And we see indeed that the zinc is above the hydrogen. And so the first thing we can just write is the gas that we know is going to be produced, which is H2 gas. Then I need to get the other product. So I like to write the zinc and the chloride separately and put their individual charges. Claudia, charge on zinc. Good job. You remembered it from earlier? Charge on Cl, -1. Okay, give me our crisscross product. ZnCl2. We now turn to what table? Table F. Find your chloride ion in table F and see if it's in the aqueous or the solid or insoluble column. It is indeed in the soluble column. Is zinc one of the exceptions for a halide? No, it's not. So we say that this will remain aqueous. I said exceptions. Sorry. Next, we need to balance that equation. What do I do? 2 in front of the HCl looks like exactly the ticket. Very good.
Yeah, give us a challenge.
I would love to give you a challenging one. Here we go. Let's try the following. Let's say that I took iron and I wanted to react it with nitric acid. This would be aqueous. Go ahead and try the product on your own. First thing you have to determine is, will a reaction actually occur? And then if the reaction will occur, what are the two products? Will the reaction occur? Yes, it will. We know then one product has to be H2. Now the question is, can we get the salt? And let's say, because iron can be +2 or +3, let's say we're dealing with iron 2. So the iron ion here is +2. Okay, so what is going to be the salt that forms between iron +2 and the nitrate ion? Good job. Fe NO3 in parentheses, and then a 2 on the outside. And I now need to find phase using table F. So it is aqueous because, Cassie, what are the exceptions in table F for nitrates? There is none. Very good. If you remember from when we talked about this earlier in the year, anything dancing with Mrs. Nitrate is always aqueous. Okay, next. What are neutralization reactions? Yeah, these guys involve reacting an acid and a base, and you get two products. What are they? A salt and water. Recognize something very important. Don't use table J for these because they are what type of replacement? Yeah, very good. Don't use table J because you're dealing with double replacement reactions. And we know for double replacement, we don't need to use table J. This is a square dance, so both couples exchange partners. So let's see if we can write the following. Let's start easy. HCl aqueous reacts with NaOH aqueous to produce what? Hydrochloric acid, sodium hydroxide, probably the most well-known acid-base reaction out there. We're going to, hook these up. So we've got here our arrows showing our double replacement. We still need to do the crisscross. So Na, which is plus, will go over and it will be joining with Cl, which is negative. Do the crisscross to get, as Zoe just said, NaCl. And what is our phase for NaCl? We know from life experience, salt dissolves, so it's aqueous. Then H plus comes over and joins with who? OH negative. We do the crisscross, and what do we get? We get H2O, and what is the phase? Nope,
Liquid,
because it's
just
pure.
kidding.
Very good, it's liquid. Next, we check to see if we can balance, and what do we find? It's balanced. Okay, now, there's something called net ionic reactions. What's that? We still have time for one more example. Net ionic reactions for acids and bases are always going to be as follows. An H plus reacting with an OH negative to yield water. An H plus reacting with an OH negative to yield water. That is called the net ionic reaction, and what it does is it gets rid of what are called spectator ions. Okay, and we haven't talked a lot about that, but I want you to just recognize that the net reaction will always be H plus OH negative yields H2O. Okay, real quick, try this one. What would be the reaction between H2SO4 and CaOH2? You try it on your own, and then check it with mine while I go back to get our demo ready.